Hello again. Okay, let's go ahead and do quest 14 of the Everybody Codes 2025 challenge that was released in November and is now being done by me many months later. I have set up my boilerplate as I've been doing it the last several problems with a part constant that I have to remember to update from 1, 2, and 3, and those are my standard problems. Anyway, yeah, let's start the timer and get going. Start timer. Okay. Quest 14. Just setting all the dials. Tell this curve several times and strange symbols, they appear to disappear, creating prison cells, the glow symbols, dragon ducks. The lizard is immediately transported into one of the cells and becomes motionless. On the opposite side of the chamber, glass orb coursing with energy. That's the source of these mysterious signals. The whole place is one giant trap set for the dragon ducks. Maybe if you manage to destroy the orb, predict which tiles will soon display magical symbols, so you safely observe the changing pattern rule. Tiles change their state in rhythm with the pulsing of the glass orb. Pattern of the next round is current state and state of the tiles diagonally. Active. Remain active if the number of active. Across all 10 rounds. $18, $19. Okay. Across 10 rounds. Okay. Right. Grid. Make. Grid, append grid. And I'm using scanner.txt there instead of, I'm using scanner.txt and we're converting it to bytes instead of using scanner.bytes because scanner.bytes will reuse the array. And I need to use a brand new array each time. Either that or I need to use a slices.copy or something like that. Okay. For scanner.scan that. Okay, and then round 1 to 10. Okay, so for round range 10 for row new grid. Make byte 0. Okay, so neighbors for and now we do and call row diff plus row idx and call diff plus call idx if 0 if 0 less than equals to n row and n row less than len grid and 0 less than equal to call and call and call less than equal to len row and grid bracket n row and call is that neighbors plus plus. Okay, so what do we have? We have inactive, odd, tile is active. It will remain active in the next round if the number of active neighbors is odd. Okay, so including that, so actually we could just do like diagonal neighbors plus me. If it's odd, then it's inactive. If it's even, then it's active. Yeah. Diagonal neighbors plus the thing there. If it's then it's active. If ch is pound if neighbors sent to is 0, new row dot append else new row append new row dot total live plus plus grid equals new grid. Okay. For range 10, there we do that. Yeah. So if the total number of diagonals plus us is... Okay. I think it looks good. Let's download. Oh. Shoot. Go run quest 14. Oh. That should be a less than 503. Yay, good. Instead of range 10, it is n rounds. What do we have? 12025. Right. Yay! Ooh, definitely across the... Yeah, it destroyed the mechanism. To calculate the new process, start from the moment when the entire 34 gone dark and all tiles were inactive. So he starts all the tiles lit up. To calculate the new process, you decide to start from the moment when the entire 34 by 34 tile grid had gone dark. Okay. They are all tiles lit up. All tiles lit up. Okay, so this is a little bit odd. Okay, so okay, so what if we just go up to round 125 and we then print it? Okay, so I need to learn about. So we have these this game of life dealio. Okay, so we have this game of life dealio, and we need to figure out. Okay, I'm just going to simulate an empty grid for 125 rounds and print it out and make sure that it really is what's going on really is what I think is going on. 125. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Copy, paste, paste, paste. 1, 2, 3, 4. Now let me just check that the length of that is in fact, that is at column 30. That should be at column 64. Yep. Okay. Yeah, for now we're just going to do that. And then here for range grid print line string of row. Okay. Okay, so I want to do this for 125 and then okay, so it really does start with empty, and then we go there, and it starts blinking. Well, so obviously we have some symmetry going on, so we can simulate just 17 by 17 and do that with a little bit of wraparound there at the edges. But then the number of rounds here is a little bit odd. Yeah, so it's they want us to simulate 1 billion rounds. And that's going to be a little tricky. The question I have is, can we detect some kind of pattern in each of these that blinks at some specific rate? Okay, I'm gonna print line okay, I'm going to be printing that. Right. One, two, two. Okay, I don't see 1017. Okay. Okay, so clearly there is something else going on here. Some other way to simulate this. I need a way to simulate what is going to happen at a specific spot, you know, a billion rounds into the future. And now I should be able to tell, like it should be pretty easy, right? Because okay, so obviously if there's some state where we get an actual repetition, such that all of the things are the same, that would work. But I don't know that we actually get there. So the question is, how do we simulate this far into the future? Okay, so what could I do? I could okay. So another way to view these is if they are, yeah, so they become active when the total sum is even. So every time we do this, we are effectively adding one to every spot, and we are adding all of the neighbors. Now, if I want to simulate one spot, I don't need to consider anything that's, you know, not diagonal there, because that one. Okay, wait a second. So at 0 rounds we have 0. After 1 round we have 1. Two rounds, we have 2 plus that is a third 1. After 3 rounds, we have I wonder after the first 34 rounds, okay, so one. After 2 rounds, we add okay, what if we look at something that's in the middle, closer to the middle? Okay. We're seeing the okay, we're just seeing the odd and even notification of that whole thing plus 1. Okay. What if I do, I'm going to figure out which round numbers actually match this. Okay, that's not great, but whatever. Okay, in rounds. This is obviously I won't do this in general, but I've got to do this enough to figure out a pattern, because I'm not able to determine the pattern by myself. Okay, for row, okay, so if we have 60, we have 17, so up to index 0 to 16, so if we had a mid-row length of 2, then we would say cent call plus plus. If row bracket cent row cent call equals mid-grid bracket if Yeah, I'm just gonna have to do that. Okay. Well, okay, so this is actually kind of familiar. 6317602618 621571. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there appears to be a pattern of 16 in there. Okay, so 6 to 33, that's plus 27. Okay, that's plus 27 as well. Okay, so it looks like we have a pattern every 190. Okay. Now, let's figure out if okay, so 602618. Okay, so 52, 536, 624, 520, 524, 604. Okay, so I say we do this for okay, so I think it is repeating. I think it is repeating exactly. So what we have to do then this will be okay, so we have to wait for the pattern to establish itself. I don't know how many times it takes for the pattern to establish itself. I'm going to say skip the first 1,000 things that it matches. So initial wait 1000. And then this is reference grid. Actually, here what I'm going to do is var reference grid of type byte. Okay, reference grid is 1000. Okay, so what do I want? I want rounds and tiles that match the sample pattern. Okay, so if center matches ants plus equals living count. Okay, now for round 0, round okay, now initial weight minus minus if reference grid nil. Okay. Reference grid equals make byte 0 if initial weight equals 0, okay, initial grid reference ants equals ants for underscore comma row colon equals range grid reference grid dot append slices dot clone row. Great. Okay, reference grid equals range grid else for row IDX range grid range row if ch reference grid row IDX call IDX okay for matches reference equals false, matches reference is true, and then if matches reference. Okay. Reference round. Copy. Reference round. Okay, reference round equals round. If matches reference, then reference answer okay, then int increment equals okay, so answer plus equals living count. And means that before yes. So we must go all the way up to yes. Okay. I'm just trying to make sure I'm not getting a silly off by one issue here with when I add the living count. So the living count will be how many things we increased. Did all of those rows? Yeah. And actually what I'm going to do here is I'm going to remove that from there and I'm going to add it onto here. No. God damn. Okay, so I've that. And actually okay. And then if the answer increment ants minus reference ants. Okay, the round increment round minus reference round. And then what I want to do is I want to add to round enough of those reference rounds to get me to within a round increment of the final value. Okay, cycles to add equals n rounds minus round divided by round increment. Okay. Just because. And then what I'm going to do here is I'm going to say round plus equals cycles to add times n rounds s plus equals s. Then I'm not going to do this again. Yeah. Okay, why didn't I ever... Reference made. Okay, so mine never... Okay. Okay, so I think I do in fact make the reference. Yeah. Okay. Nope. Okay, so I'm off I'm doing something that makes me off by some number. Okay, well, let me check that. Why not? Let me save it as that. Um, 88552. Okay, so I'm not off by a whole lot. So let me. So first of all, I'm surprised at how long it's taking to get through the initial wait. So let me center matches round. Jumping from round. Okay. 2056 to round. Whoa, that's weird. Oh. Well, that could be a problem. I mean, that could be a problem. 552. Okay, so that's much better. Yay! Okay. Well, yeah, took me over an hour. I'm kind of surprised at how long it takes to find the reference. Can I jump the initial wait down and still get there? Yes, I can. Okay. The initial wait here is just because I worry it might take a while to fall into a pattern. Maybe I can do with an even smaller initial wait. Yeah. Okay, so I still don't know how to predict this pattern, but I guess I don't have to know how. Okay, that's a perfectly acceptable time. Okay, not sure I really need to do any cleanup here. I mean, I'll leave the debugging statements in. Okay. Commit, push. Okay, thank you for watching all this time, if you have been, and we'll continue on with this. I don't think I'll do another one today, but we'll continue on with this, and I will try to get the rest of these done this week. We've only got 6 more to go here on the 2025 challenge. Okay, I may not finish all of them this week.